which this whole part is the header, but this magic number on the top indicates that this is an executable file and identifies it as such so the operating system knows and can execute it. So this, on the bottom here, symbol table is used for debugging the executable file. So when the file is executable, it has a special format so that the operating system knows that it can execute it. It's a binary file which has a special format. The rest of the files, we have block special files. So because the disk is separated into blocks, we can have certain files which try to help with the organization of the disk by following the disk structure. So we create the files in this special block format. So these are used to model disks. Then we have regular files. These files are either text, so they are, which means they consist of ASCII characters. That doesn't mean that it's a text file that is human readable. It could be some code, but the point is that it's written, it contains characters, so we consider these ASCII files. So they can be either that, because it consists of lines of text, or they are binary files. Which means they are not ASCII, and if we try to print them, the printer will just output some random junk. So the file allows us to store some information on the disk, but from user point of view, it has a bunch of properties that the user is concerned with. Some of them we mentioned earlier, such as the name of the file. the size of the file, and other things like when it was last modified, who created this file, who was the owner to the file, who has permissions to read, write, or execute the file, and many other properties. So creator, owner, is it readable? Is it read-only? Some files can be hidden because they're needed for the control of the machine, and we try to not allow users to either see, modify, or delete these files. So we do have hidden files. Some files can be archived, so there's a flag for archiving to show whether the file has been backed up or not. And there's a flag which says whether the file is text or if it's a binary file, and so on. There are many properties that the file can have. We mentioned before that in order to do any manipulations of files, we need to go through the kernel. So we, in user mode, and any user programs are not allowed to directly manipulate files. So if a user code is running and wants to open a file, then it needs to trap into the kernel and let give control to the operating system and let the operating system open that file. And so that's just one of the system calls that we have available for files, is to open the file. But any other operations which we need to do on the files, such as to create the file, we need to go through the kernel and let the operating system do that. So when we create a file, we basically set some attributes for that file. The attributes is what we said earlier. We have to give it a name. We set other things like the time it was created, its size, and so on. What happens if we start having too many files? Can we fill up the whole disk with that? We can, and if we fill it up, then we have to go and delete some of them. So we would delete them to free up disk space. Okay, before we do anything with a file, before we can do anything with a file, we need to initiate a system call called open the file. Why does the file need to be opened before we do anything with it? Does anyone know? What's the purpose of yes?
So the system knows that no other process should be able to access that file and possibly modify it when that other program has it all in open.
Okay, so he's saying the process should be able to access the file and maybe let other programs access it. Very good. But we need to about this file before we can do processing with it. So that's why we first need to open the files. And why do we need to close the file? So let's say we are programmatically opening a file and we wrote something into the file. And our program is finished. Why do we need to close the file before we're finished?
To ensure it stops taking up RAM.
So it stops taking up RAM and to ensure nothing that's accidentally gets read into the file.
Okay, very good. So that it frees up the memory because it's taking space into the RAM, which is into the file allocation tables of the operating system. So we're going to free up some space into these tables. Internal table space. If we want to read or write into the file, we have to make system calls for that. We have others system calls. Append is a special form of write where we add the information to the very end of the file. And seek is a system call which allows us to look for a particular position inside the file. Other operations we might want to do with the file is just read its attributes or change any of the attributes and to rename the file. So if we look at some code here, which is trying to manipulate files, so it opens a file. So when we make this call open, we are doing a system call. So when we try to open the file, this program stops its user mode operation and the system call open is initiated and we trap into the kernel. When the operating system is finished, return control back to the program right in this line where we left off. Same if we try to create a file or do any other file operations such as read, write, and close the file. Okay, files are great, but if we have too many files, then we might want to organize these files in some logical way which makes sense to us, the users. Originally, the first systems did not have directories, which means there was only one directory, the root directory, and whatever files we had went into that root. So this is called a single level directory system. Now, in order to keep track of files,